This is Unit 2 of Python programming, titled Python Decision Making and Loops. In this unit, we learn how Python takes decisions using conditions and how tasks are repeated using loops. Decision making is done using if-else, and elif statements, which work on Boolean expressions. Loops such as while and for are used to execute a block of code multiple times. We also study control statements like break, continue, and pass, which control the flow of loops. Finally, we learn how loops are used with lists, sets, and dictionaries. Decision-making in Python means that the program can take different actions based on conditions. A condition is an expression that is evaluated as either true or false. Python checks this condition before executing the code. If the condition is true, a particular block of code is executed. If the condition is false, that block is skipped or an alternative block is executed. Decision-making helps us control the flow of the program and is very useful in real-life applications, such as checking pass or fail, even or odd, and grade calculation. A Boolean expression is an expression that returns only two possible values, true or false. These expressions are created using comparison operators like greater than, less than, or equal to. Boolean expressions are the foundation of decision-making in Python. They are used in if statements to take decisions and in loops to control repetition. For example, when we compare two numbers, Python checks the condition and returns either true or false. The if statement is used to execute a block of code only when a condition is true. Python first checks the condition written after the if keyword. If the condition is true, the indented block of code is executed. If the condition is false, the code inside the if block is skipped. Indentation is very important in Python because it defines the block of code. The if statement is commonly used in programs like pass or fail checking. The if-else statement is used when we have two possible conditions. First, Python checks the condition written in the if statement. If the condition is true, the code inside the if block is executed. If the condition is false, the code inside the else block is executed. This structure is commonly used in real-life programs such as pass or fail, eligible or not eligible, and even or odd checking. The elif ladder is used when we need to check more than two conditions. The word elif means, else if. Python checks conditions one by one from top to bottom. As soon as a condition becomes true, its block is executed and the remaining conditions are skipped. The else block is executed only when none of the conditions are true. The elif ladder is commonly used for grading systems and category-based decisions. Loops in Python are used when we want to repeat a block of code multiple times. Instead of writing the same statement again and again, we use loops. Loops help reduce code length and make programs more efficient. They are commonly used in tasks like printing numbers, calculating totals, and processing lists. Python mainly provides two types of loops, while loop and for loop, which we will study next. The while loop is used to repeat a block of code as long as a given condition is true. First, Python checks the condition written after the while keyword. If the condition is true, the code inside the loop is executed. After execution, the condition is checked again. This process continues until the condition becomes false. It is very important to update the condition inside the loop, otherwise, the loop may run infinitely. The for loop is used to iterate over a sequence such as a range, list, or string. Unlike the while loop, the for loop does not require manual condition updating. Python automatically takes the next value from the sequence in each iteration. In this example, the range function generates numbers from 1 to 5, and the loop prints each number one by one. The for loop is simple, readable, and very commonly used in Python programs. A nested loop means a loop inside another loop. First, the outer loop starts and runs one iteration. For each iteration of the outer loop, the inner loop runs completely. After the inner loop finishes, the outer loop moves to the next iteration. Nested loops are commonly used in pattern printing, tables, and matrix-based programs. Students should carefully observe how many times the inner loop executes. An infinite loop is a loop that runs continuously and never stops on its own. This happens when the loop condition is always true. In this example, the condition is written as true, so the loop will keep printing the message again and again. Infinite loops are generally avoided in beginner programs. However, they are used intentionally in applications like servers, games, and real-time systems, where continuous execution is required. The break statement is used to stop the execution of a loop immediately. When Python encounters the break statement, it exits the loop completely. In this example, when the value of I becomes equal to 3, the break statement is executed. As a result, the loop stops and no further values are printed. The break statement is very useful when a required condition is satisfied and no further looping is needed. The continue statement is used to skip the current iteration of a loop. When Python encounters continue, it does not execute the remaining statements of that iteration. Instead, control moves directly to the next iteration of the loop. In this example, when the value of I becomes 3, the continue statement is executed, so 3 is skipped and not printed. The loop then continues with the next value. Continue is useful when we want to ignore certain values but keep the loop running. The pass statement is a null statement in Python, which means it does nothing. Python requires a statement after if, for, or while, and pass is used when we do not want to write any code yet. In this example, the condition is checked, but no action is taken even if the condition is true. The pass statement is useful during program development, especially when we want to write the structure of a program first and add logic later. Loops are very commonly used with lists in Python. A list contains multiple elements, and using a loop we can access each element one by one. In this example, the for loop takes one value from the list in each iteration and prints it. First, it prints 70, then 80, and then 90. Using loops with lists helps us process data easily, such as calculating total marks, average marks, or finding the highest value. A dictionary stores data in the form of key and value pairs. When we use a loop with a dictionary, Python accesses one key at a time. Using the key, we can also access its corresponding value. In this example, the loop first takes the key name and prints its value. Then it takes the key age and prints its value. Loops with dictionaries are very useful when working with structured data such as student records or employee details. Python provides many built-in functions that work very well with loops. The range function is used to generate a sequence of numbers, mainly with for loops. The len function is used to find the number of elements in a list or other collections. The sum function is used to calculate the total of numeric values in a list. Using these built-in functions makes our code shorter, clearer, and more efficient. Programs based on decision-making and loops are very important for exams and practicals. Common examples include checking whether a number is even or odd, calculating the sum of numbers, and printing multiplication tables. These programs use if-else statements along with loops. Practicing these programs helps students improve logical thinking and problem-solving skills. Python is not only used for calculations and logic, but it can also represent data graphically. Plotting data helps us understand trends and patterns more easily than numbers alone. In Python, simple plots like line plots and bar plots are created using libraries such as matplotlib. In Unit 2, we only focus on a basic introduction to plotting, just to understand the idea. Detailed plotting will be covered in later units.